So now in this video we have a NOT gate inverter. I have to get it pretty dark, but any case we can get it dark enough where the LED starts coming on right there, and we could wire this better, but this is more for a demonstration of the NOT gate. So we have a transistor right here, NPN Bipolar Junction Transistor. I'm using a 2N3904, and there's no Schmitt trigger effect here. We have a fade that kicks in, as we saw. But in any case, when we have enough light, we want a higher voltage at the input, and thus the LED will turn off, basically. The output will go down. And then when it gets darker, then we got less base voltage, and the LED gets brighter. And so you can see that here. NPN Bipolar Junction Transistor, since we have a variable resistor here, that resistance goes down a lot when you get light on it. We need to make sure we limit current through base to emitter. Be aware of that. But otherwise we got a voltage divider. So brighter light raises the voltage at the base. And then when it's darker, then it's like this resistor doesn't exist if you get dark enough, because the resistance is so high, and we get a lower voltage at the base. Make sure the transistor turns off. Now when the transistor is off, let's cover all this, it's off, then we have a current path through the LED right there, and the LED will light up. And the main reason why this is not a practical circuit, if you want a NOT gate, in this case we want the LED to turn on when the transistor turns off, is because right here this is fine, but when the transistor is on, the current going through the 510 ohm resistor all goes down to ground. So you actually have more current flowing when the LED is off. So LED is off right now. There you can see 9 milliamps of current right there. And I have the lamp at the lowest setting, so this may turn it on completely. But there you can see 6 milliamps of current. I'll turn that light on, and yeah, it looks like it's holding at 6 milliamps of current. If I take the cap off, there you can see it went up. Actually, yeah, that's not even dark enough to get the LED to light up. That current's all going through the transistor right there. So this is not a practical circuit, but this is actually still a good circuit to memorize. Circuits like this, this particular circuit's not terribly great, but there's a number of circuits that pop up that are similar to this. So you may have a signal that maybe changing a bipolar junction transistor, but what you're interested in is the inverted signal coming out. As the transistor conducts better, that voltage goes down. As the transistor starts turning off, not conducting as well, this voltage goes up. So you'd use a higher value resistor so that the current going through the transistor is far lower, but you'd be passing that along to other circuitry, like a voltage follower or something. And so that would take the voltage that you're giving it and either output a higher voltage or be able to power an LED. And so when you turn off that circuitry, it's not wasting any current, and you have a higher value resistor, there'd be less current leaking through the transistor right there. Hopefully that makes sense. Not going to go into that too much more. Just be aware, there's similar circuitry like this, where you have a signal and you're outputting the opposite signal for the most part. And again, this is not Schmitt trigger. It's not quite a switch. We can get the LED to a medium light level. It doesn't go right from on to off. There we go. I got like a medium light level there. So we can do this directly like this, but it wastes more current. It'd be better to send this to like a voltage follower, so hopefully that makes sense. But in any case, that's it for this video. Hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.